Hello and welcome to this tutorial on zone designation in Unity. I'm not really sure what to call the mechanic. As far as I know, there's no single name for it, so I've just settled on calling it zone designation. What the system does is allow you to draw rectangles on a grid in 3D to designate areas of the map, and rectangles that are touching or overlapping will be joined. In these examples, you can see distinct areas are identified with unique colors. You can also delete areas, test points on the map to see which area they are in, if any, and count the size of areas and how many there are. All this is done with some pretty simple maths. There's no colliders or anything like that needed. I use this system in my game, which is a city builder about religion. If it looks interesting to you, you should consider subscribing to keep up with development. The system was inspired by games like Prison Architect, where you draw rooms down on the map, or Banished, where the player can designate certain areas as stockpiles. Quick disclaimer, what this implementation does is allow you to designate unique zones and distinguish each of them from one another with a unique ID. What it does not do is pretty much anything else. This is a fairly bare bones implementation designed to be built upon for specific use cases, rather than something that is actually useful by itself. Disclaimer part 2, this is more of a walkthrough than it is a tutorial. I'm going to walk through the code and explain the systems to give you an understanding of them and the logic behind them. I'm not going to code the whole thing on camera because then we would all be here for ages. The source code and the handy sample project though are in the description. So to begin, there are basically 4 scripts that we care about. Grid, which, believe it or not, handles the logic of the map grid. Draw zone, which allows us to draw rectangles on the map. Rect union find, which houses the data structure that we're going to use to hold all of the rectangles. And zone manager, which takes the rectangles from draw zone, manipulates them, and organizes them into distinct areas. So we're going to start with grid. The visual representation of the grid that you see in the game is actually just an image overlaid on the terrain. This script handles the logical dealings of grid functionality rather than the visual ones. Another disclaimer, this code is pretty much ripped straight from Jason Wyman's video on grid systems, which I will link below. All the script does is provide us with a function that will return a point that conforms to the grid when passed in any point in space, and we'll use that to make sure that our rectangles are always lined up with the grid. Next up is draw zone. This script is used to draw rectangles on the terrain when the player clicks and drags. When the mouse is released, the rectangle is then sent to zone manager. So again, it's a pretty straightforward script. We get the mouse position on the terrain using this method. It's worth noting that my terrain is always flat, so I've hard-coded in the Y position, which won't work if you have a variable height terrain with things like hills, etc. Also worth noting that I've got a layer mask set up for the terrain, and this will ensure that our raycast only registers hits on objects in layer 8, which is my ground layer. Using that method, we capture the 4 points of a rectangle when the player clicks and drags their mouse. The first point is the location of the mouse when the mouse is pressed, and while the mouse is held down, the 4th point follows the cursor. We can then extrapolate the 2nd and 3rd points pretty easily from the 1st and last ones. While the mouse is being dragged, we're constantly updating our mesh, which again is a fairly straightforward process. When the mouse is released, we send the data as a rect to our zone manager script to be organized. It gets sent to different methods depending on if we want our drawn rectangle to be added as a zone or to delete from any zones that overlap with it. So before I dive into the code on how the zone manager works, I want to briefly explain the data structure that it uses underneath to track which rects are touching which other rects. It's called union find, also known as disjoint set. The basic idea is that individual data items, in our cases the rectangles that make up a zone, each have a pointer to another data item. Performing a union operation between 2 items makes one point at the other. As you can see in the example, each set ends up with every pointer eventually arriving at a data item that points to itself, and this is called the root of the set, and it's used to track which set a data item belongs to. Because if you follow the train of pointers, every data item in the set has the same root. Our implementation uses integers to track which set a rect belongs to rather than pointers to other rects. This is so we can easily use a number to identify different unique zones. So performing a union on 2 rects changes the root attribute for all of the rects in both of the sets to be the same value. I'll put a link to the visualization tool in the description as well in case my explanation didn't convince you. So onto zone manager. Once a rect has been passed in from the draw zone script, it arrives in the add rect method. We then add it to the union find data structure, which will initialize the rect with its own unique root, i.e. it is treated as separate from all of the other rects on the map. We then run a method to find which rect this one is touching, and should therefore be unioned with. The code to check if 2 rects are touching or overlapping looks like this. We also need to prevent rects from overlapping, meaning that no one grid square can be occupied by more than one rect. This is done in the add rect method by finding any rects that we have an overlap with, and calling cutout overlap on one of the rects involved in the overlap. What cutout overlap does is replace a given rect with a number of rects that make up the original rect minus the area that has been marked to be cut out. We calculate the fragments of the original rect using a method called cutoutRect, which returns an array of rects that make up the new shape. We can then remove the original, add the fragments, and union them all to their neighbors. The delete method is actually very similar to the way that we prevent overlaps. If drawZone is in delete mode, the rect the player draws will be passed into this method, but obviously the rect that the player drew is never actually going to be added to the data structure because it's a delete area. So if we just treat it like we're removing an overlap between two rects, the one that actually exists will be removed, and the other is never even drawn, so it leaves the area blank. We then force any rects that were affected by the delete operation to recalculate their unions from scratch. This isn't as efficient as I would like it to be, but it's the easiest and most straightforward way of dealing with some of the edge cases that I had crop up when I was creating this. Finally, the last piece in our puzzle is actually drawing the meshes that represent the rects to the screen. We're using a boolean that is set to true every time a change to the data structure is made, which is then picked up an update, and a method is called to draw a new mesh for every distinct area in the data structure, which, as you'll recall, is represented by a unique root value. That's all I've got for you on this one. Once again, you can see the source code and the sample project in my GitHub down below. Hopefully you found this helpful. It's not really something that you can just pull straight off GitHub and it'll immediately work for whatever your use case is, but it should be a pretty good starting point that you can jump off from, and it should save you some of the mental energy needed in making a system like this. If you enjoyed the video or you want to keep up to date on my city builder project, consider subscribing, and if you have any questions, feel free to let me know in the comments.